So with the test, I want to first talk about Respondus, and you can find that information in modules. And down here with instructions for Respondus, just click that. And this is straight from them. And the main link here is this second one. This is where you can download the browser and install it. And they have a setup that you go through to help get everything working. And once you have the setup working, you have it installed, you went through their setup, then you just come back to the Canvas page and go to quizzes. And both of these are set up for Respondus. So here's the real deal quiz. Test. I can't change the name quizzes there. And here's the practice one that you absolutely should check out first. It's practice, it's not worth any points, just so you can know what's going to happen before you're actually put to the test. So I'll just click that. And there's two types of questions here. There's going to be questions where you just fill in a box with a number or DNE. So all the boxes will accept a number or DNE. And then the other type of question is this essay type of question that it classifies it as. And this is the only place where I can find you have access to the equation editor. And this is obviously usually important for math, that you're allowed some way to insert an equation. And this is where we can do that with the essay format. And here's a problem you've done before. And I want to show you what I'm hoping will happen here. And so I have the criteria here to show at least 2 steps of work. And then these were the questions you had for MyMathLab. What's the largest open interval about C? And then the largest value of delta that will put that centered interval in there. So what I'm hoping here is that you will just insert your work as you would do it. So the first thing we want to do here is plug the function into the centered interval on the output. So we'll just stick the square root of x in there, and the limit is 2. And I'm saying epsilon here is 1. These will all be brain friendly. You won't need a calculator for any of this. So we're going to have to use the equation editor right here. And we want an absolute value. And that is shift slash, the slash that's right underneath backspace. So if you hit shift that slash, you get that up line there. That actually gives you the absolute value. And so we're going to stick in there the square root of x minus 2 for our limit over here. And all that is less than epsilon, which is 1. And there's the first line of work. Just plugging the information in. And the next line that would probably be shown here when you're doing this by hand is to break this into double inequalities, or one double inequality. And so there we go. And the next thing you want to do here by hand, if you're doing it on paper, hopefully you are, is add 2 to both sides. And there's the next line of work. And then to finally solve for x, square everything. And there we go. So just by doing this, I've already satisfied show at least 2 steps of work. So there's at least 2 steps. I've already shown 1, 2, 3, 4. And then right here, is our, well, I've actually shown 3, because here's our final answer then for part 2, the largest open interval about C. There it is, 1 to 9. And then for part 3, this is where you choose the largest delta that squeezes the centered interval into this one. So our centered interval is about 4. So if we stick a 4 in here, we can go 3 to the left or 5 to the right. And we choose the smaller one because that will put the interval then within this one. And so we get a delta of 3. Greek symbols, there's the delta. And there's everything. This is showing the work. Here's the answer for part 2. Here's the answer for 3. And if you did this, this would be awesome, because then I can see what you're thinking, getting some idea as you show me your work. You got your answers. This would be cool. So this is what I'm hoping will happen with these essay type questions, using the equation editor and just showing me these lines of work. And here's another example. So find this limit, show at least a step of work, the final limit that before you solve it, and then what that final solved answer is. So, well, if we plug in 2, we get 0 over 0. So the indeterminate form, there must be something more we can do there. And you can't get anything under the limit, so the best we can do here is use the subscript. And under arrows is where you can find the arrow. And basic is where all the most used stuff is, like the subscript and superscript and the ratio here. So factoring this numerator, and there it is. And then the denominator, and so there's a line of work. And the next thing we would do here is divide out these x minus 2's. Oh, I guess nothing in the denominator anymore. Just got x plus 3 there. And just to be nitpicky here, no, I would not get nitpicky here if you use parentheses or not. Don't worry about that. If you're showing me your flow of logic here, I'll most likely get it pretty quickly, and I'll understand, oh, there's no parentheses there. That's cool. I mean, you really should include it, but don't worry about some ticky-tacky stuff like that. And then now we can just plug in 2. And there's our answer then, 5. And so there you go. I showed at least one step of work right here doing the factoring. The final limit before solving, so that's this right here. Here's the final limit before we solved it, and here's then our final answer. So again, if you did this for this problem, I think that's great. This is what I'm hoping for. And as a final example, using the definition of the derivative, and we want to find the derivative for 2x minus 1. So we will also need x plus h here. So we'll plug x plus h into the function. And that's showing some work. You know, if you did this, you'd be telling me, hey, I get it. I got to plug x plus h into this to solve this. And the next thing we would want to do is plug all this stuff into the limit. And we have f of x plus h, which is what we just figured out right here. And then we subtract off the original function. You're going to definitely want to use parentheses here so the minus sign distributes correctly. And there's another piece of work. Again, if you showed me this, I'd be like, oh, okay, they're getting it. And the next step would be to clean this up. So do some distributing, some subtracting out. So we would have distributing 2x plus 2h. There's our minus 1. And then minus 2x plus 1 all over h. And there's another good step. And now we can do some subtracting out of stuff. So the 2x will subtract out. The 1's will subtract out. And so we have 2h over h. Oh, whoops, what happened there? And the h's divide out. And then here is our final limit before solving. So that's what I mean by this statement 2 here. Show the final limit before solving. There it is. Because now we're going to solve it. And the limit of a constant is always that constant. And there's our final answer for 3. So again, if you did this, I'd think that's cool. And even if you make a mistake in here, I'll be able to see it. And then I'm able to give you partial credit then, based upon, what happened here. So that's the practice test. This is exactly what you'll see when you do the practice. And the computer will grade you on these inputs, these boxes here, but I will manually grade the essay ones. So it's probably not the smoothest transition there, But here we are at My Math Lab, or My Lab Math, I guess is what they call it here. I'm so used to MML. And what I've put in here, if you check out assignments, is this practice bank test. These are all practice, not worth any points. But what I like to do is I like to go through all your assignments through practice and homework and choose the problems that I think would be good for a test. Some problems are better for homework, and some of those problems I think are good for a test. And so I go through all of those, and I pick out the ones that I think would be good for a test. And that's what this is. These are those problems that I chose and for problems that are good for a test. And the test questions are from this bank. Now, I did change the numbers, but if you want to know what to expect on the test, well, the test has 22 questions, and they are all from here. And so it will cover everything. 2.2, 2.3, 2.4, 2.5, 2.6, and 3.2. And the only things that I really took out were things that are more time consuming. So there's no tables. You don't have to create any tables. So it just occurred to me that I can actually just upload a real test that I've given in the past. And if you go to Course Tools and Document Sharing, here is the last semester test for in-person 221. And so it's all blank. You want to print it out blank and check it out for yourself. And then at the end is where I work it all out then. So something else you can check out if you find that helpful. And you've also got the practice test bank. So for the test, I'm going to give you time and a half. So it's 150 minutes, just because I'm not sure how slow things will go with the equation editor interface there. And there's no notes, no book, just you and some scratch paper. All the problems I've chosen with the understanding that you don't have a calculator. So don't worry about taking square root of 3 or something. All the problems will be simple numbers that you can do in your brain without a calculator. So there's everything I have to say. I hope this all sounds fair and reasonable. And of course, I hope you're learning some calculus.